Video number 18 in how to make a chess program in Go, the language Go. So far we have managed to generate all the possible moves from one position, but there is one thing that we still haven't fixed, and that is 3 different rules about check, being in check. Let's do some moves here to illustrate my point. And here the black king is in check. And in fact, most of the moves here are illegal. A6, for instance, or B6, or black cannot leave his king in check. But king f8 is okay, of course, or bishop d7 is okay. Let's say white make a castle here. Now black cannot move his bishop because he cannot make himself in check. It's the same basic rule, and all is about not being in check after you made your move. And the second rule is that you cannot castle when you are in check. That is before the move. You cannot castle now, even if after the move is done, even if after you make your castling and you will not be in check after that, you are not allowed to make that move. So we need to look if the king is in check before the move. So we cannot be in check after the move like this, and we cannot castling when we are in check before the move. So let's make some other moves here to another position. And now we have the third move rule about check, and this is also about castling. Black is not in check here, but cannot castle. So the king cannot pass an attacked square like this. And even here, black is not in check after the castling move, but it's still illegal because you pass attacked square. So we have 3 rules. You cannot be in check after you made your move. And if you are in check before you make your move, you cannot castle. It's illegal. And you cannot castle if you need to pass an attacked square. These are the 3 things that we need to implement. And that is exactly what I have done. So let's take a look at the code. I have this is attacked function. Is a square attacked by a certain color? I don't care about who is side to move. It's just if a square is attacked by a certain color. And when it comes to pawn attacks, it's easy. We just shift northeast and northwest. For the other pieces, we just get the attacks from that square, and we check if we attack a piece of that sort with the color that we are testing. For instance, knights, we get the attack table for knights from that square, and we see if it's hit the knight. In that case, we return true. Otherwise, we go on to the next piece. And that is the king, and we do exactly the same thing. We get the attacks from that square, from the king attacks, and we see if it's hit a king of the right color, then we can return true. For bishops and rooks, we can use this magic bitboard function that is called attacks. And for bishop, we get all the attacks from that square, and we see if it hits a bishop or a queen, and we can return true. yes, is attacked. And for the rook the same. We see if it hits a rook or a queen, then it is attacked. And if no one is true, then we can return false. So let's look to how to use this is attacks. So we have this move function that make a move, and it all kind of moves. And after the move is made, we see if the king is attacked. Then the king is in check. If so, it's an illegal move, and we need to take it back. We call that unmove. And unmove, just put back the pieces on the original squares, the from piece to the from square, and captured piece to the to square. But we need to take special consideration to en passant move and castling, because they are a little bit different. So if the king is in check, it's illegal, and we unmove and we return false. And here's another place I use that. When we generate all the moves, we know that some of the moves might be illegal because the king is in check. So we have this filter legals function that filter out legal moves in that move list. So we take that move list and loop through it. We make the move. If the move is okay, we unmove and go on to the next move in the move list. If it's not okay, we remove it from the move list. And now we have a move list with only legal moves. That was the first rule about checks. Now we can look at the second and third rule. And that was about castling. So I will go to king moves and look at the castlings. And here I could use is attacks as a function, because you cannot pass attack squares, etc. Instead, I use what I think is a faster method. First we check if there are any pieces in the squares between king and rook. After that we see is short to k. And short to k look like this. First, if the castling flags are okay, of course. And after that, we check a bitboard for pawns and one for knights. That we say, if you have a pawn here, you cannot castle. If you have a knight here, you cannot make a castling. So let's take a look. So, if we have a pawn on these squares, we cannot castle short. And a pawn on these squares, we cannot castle long. A2 is okay. And for knights, we can do the same. We can have a bitboard with knights on these squares. Then castling is not okay. F2 is okay, but the other are not. And even up here, we cannot have a knight, because then castling is not legal. So these bitboards for knights and for pawns are these squares. And now we have the sliding pieces left. So we put the king position in SQ square, and we can see if we are attacking E1 or E8 or F1 or F8 or G1 or G8. These are all the squares between. And down here somewhere we initialize all these bitboards. So we have these squares between king and rook for short castling, and the same for long castling. And then we have this square where pawn, if you have a pawn, you cannot castle short or long. And the same for knights, of course, and black and white. And now when we can make all the legal moves from any position, we can check how it works. So I open this terminal window. We can build the program and run it. And we print the board. We have these, our own commands, PB, print board, and try to make it fit the window here. And now we can print moves, PM, and we should get 20 moves from the starting position. That is 16 pawn moves and 4 knight moves, and it's okay. We can set up another position to see these check roles, at least one of them. This bishop is checking the king, and now we make print moves. It's for black, and we get only 4 moves. Pawn to c6, knight to c6, and knight to d7, and the bishop to d7, and the queen to b7. Now we are ready to start to play. We have all the things in place except the engine, but we can start very simple. And I would like to make some changes to this preliminary engine. So we don't need to have these stop and other case. We need only one command in, and that is go, or whatever you call it. So we make it bool, so we can send in true or false, it doesn't matter. We just send something in to start the engine. And we have this, okay, see if we can print that. We don't need the case because we have no cases. We don't need any switch at all. We just loop through commands that we get. Let's remove this. It didn't work. I just write something that we will remove later. This anonymous function I would like to have named, because that is an important part of the program. So we call that root. That root is handling. So we call that as a Go routine. That root is handling the starting position, not the start position in the game, but the position that the GUI sent to us. It will do the same thing, and I think we stop here and continue next time to prepare for playing our first game. Until next time, have a good one.